Today I show you how to find the electron configuration of any given element using the periodic table. There are 4 blocks: the S block, the P block, the D block, and the F block. Let's start with the very first element in the periodic table, hydrogen. Hydrogen is in the S block in the first period. So what we do is this. First, we write the period number, followed by the block, and the number of blocks that we will be counting. Now, what I mean by that is this. If we were to say go to helium, it would be 1, 2. So helium would be 1, S, 2. But we're not going to helium, we're going to hydrogen. So 1, S, 1. That's it. For hydrogen is 1s1. Now let's jump to nitrogen, atomic number 7. Again, indicative of how many electrons we have as well. All right, let's see how many we have to go through within this first period because nitrogen's not in there. So we see 1, S, 1, 2. 1, S, 2. Okay, now let's go to the next period. We see 2 and S. Now we have to stop here, as we can see, because the S stops in blue and the P block starts in red. So 2, S, 1, 2. 2, S, 2. Now, I've written a rule right here. It says number 5 for our periodic table, atomic number, boron, starts the 2p block. There is no 1p block. So we have 2p, 1, 2, 3. Nitrogen stops at 2p3. And that's the electron configuration for nitrogen. Now, if we do something right here, we can also see that we will get the number 7. If we add these, 2 plus 2 plus 3, we see we get 7, which happens to be our atomic number, which, as I said earlier, is indicative of the electrons we have, and we're writing the electron configuration. Now let's go into territory that may be a little bit confusing. We're going to end up going through the D block. Let's choose iodine, atomic number 53. Now, this electron configuration may end up being pretty long. 1, S, 1, 2, 1, S1, 2, S, 1, 2, 2, S2, 2p, 1, 2, 3, 4, 5, 6, 3s, 1, 2, 3s2, 3p, 1, 2, 3, 4, 5, 6, 3p6. So as you can see, we're just going through the periodic table like this, left to right. until we finally approach our iodine right here. Okay, so we stopped at 3p and 6, so now we're moving to the 4. So 4s1 2. And here we come across another rule. So we see the D block is here in yellow. Okay, so atomic number 21, scandium, starts the 3D block. So the first level of the D block is 3. So there is no 1 or 2, but there is a 3. So we have 3D 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3D10. Now don't let that confuse you and have you retract to going through the third period again. You still go through the fourth period. It's just that the D block, if we delve into quantum numbers, which I am planning on doing in the future, I will explain why that is. But for now, we don't need to worry about that. So we had 4s1 2 and 3d 1 2 3 4 5 6 7 8 9 10. Well, now we're approaching the P block again, and our P block rules still stay the same. So we are still in period 4. So 4p 1 2 3 4 5 6. 4p6. Okay, so we've gone through this many so far. We're approaching our final period, period 5. 5s1 2. And now this is the 4Ds. So 4D 1 2 3 4 5 6 7 8 9 10. Okay, now we're going through our P's again. 5p 1 2 3 4 5. 5p5. So that's quite a long electron configuration. See, we have for this 1s1, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5p5. That is the entire electron configuration for our iodine right here. The last element I'm going to go over is called Einsteinium. This way we'll go to the F block, and I can show you how we will approach that too. I think I'm going to write this on the right side right here, because this is going to end up being a gigantic electron configuration. So 1s2, 2s2, 2p6, 3s2, 3p6, okay, 4s2, 3d10, 4p6, 5s2, 4d10. 5p6. 6s2. Now here we run into another rule. These elements down here are called lanthanides and actinides. These are our lanthanides. These are our actinides. Now, let me actually make a quick correction right here because I realized that these are actually a part of the D block. Let's see, what was this? 71, 103, LU, LR. Okay. Sorry. So we were right here at 6s2. Now the other rule up here correlates with the F block, and the F block starts at 4. Now, usually in your periodic table, you may see that it says lanthanum and actinium, but maybe you'll have some type of asterisk or double asterisk here, and then it'll correlate like this right here. Most periodic tables I have seen will show you the amount of elements that it goes through like this. LA through LU, and AC through LR. That means we got to jump down here to our lanthanides and actinides. So after we've gone to 6s2, when we bump into this, it says, hey, we start at lanthanum down here. Now lanthanum starts the 4F block. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, the F block can only go up to 14 electrons, which is why I had to make this quick correction right here and put these back with the D block, because that would mean, if these were still green, that would mean that there are 15. But due to the way electron configurations work with quantum numbers, as I said again, I'll go over that in the future, they can only go to 14. But we don't need to worry about why it's 14, but just know for now it's 14. And these continue the D block after. So we actually went through all of these elements in the F block. And remember, this starts 4F. So 6s2, 4F, and we counted 14. 4F, 14. And then we hit the D block again. We already went through 3d10, 4d10. Now this is starting 5d. So 5d1, then we jump all the way back here to HF, hafnium. So 5d1, 5d2, 3, 4, 5, 6, 7, 8, 9, 10. 5d10. Now 6p6. We'll go through those. Then we start the period 7s, 7s2. Einsteinium is here, I should say that. Right here, number 99. So we're almost there. 7s2. Then we're back in the F block. Yeah. Actinides. So now this is 5F, because this starts, remember, this starts 4. So 5F, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We hit Einsteinium. 5F11. As you can see, that's quite the monster of an electron configuration. That was pretty long. Now, in case this is still confusing, I have a page on the other side that may make it easier, although I would not recommend remembering it like this. This is just so you can understand the concept of how the order goes about. Because the periodic table is written like this, not like this. This is just something that I reordered to make it easier. But if we try to go to, say, nitrogen again, 1s2, 2s2, 2p, 1, 2, 3, 4. I'm sorry. That's not right. I accidentally swapped nitrogen and oxygen because, well, mistakes happen. But 2p, 1, 2, 3. There you go. If it was 2p4, then we would have 8 electrons, and that's not correct. There's 7 electrons. So 1s2, 2s2, 2p, 1, 2, 3. Nitrogen, 1s2, 2s2, 2p3. And as you see, when we hit right here in group 6, just like we did over here, we jumped to the F block. Well, if you look at this, this is the reason why. See, our atomic number is 56, and then after that it proceeds to be 57. Instead of being 56 to 72. That's the reason why the F block interrupts the pattern that we have. Same thing with the D block. See, we have 19, 20, then this huge gap, and then 21. So that's when we hit our period 4, right here, we have to be interrupted with this D block. I mean, that's already in order, as you can see right here, but yeah. This is why the F block is interrupting us right here. The last thing I want to show you is abbreviated electron configurations. So if we go to, let's say, chlorine, atomic number 17, we can start with the noble gases and the period that precedes it. So chlorine is in period 3, and the period that precedes it is 2. Noble gas for that period is neon. So we can write neon in brackets like that. And then after that, we can immediately just jump to the next period, and we see we have 3s2. And then 3p, 1, 2, 3, 4, 5, 3p5. Let's do one more. Let's do Einsteinium again, but this time let's do it with an abbreviated configuration. So when we went to this page, we saw that Einsteinium is technically kind of in the last row right here. Period 7. So if we look at period 6, and we figure out which noble gas is at the end of this one, we see it's radon. So Einsteinium, I believe it's number 99. Yes, 99 is brackets radon. All right, radon right here in period 6, because this F block again right here, or is, yeah, it's supposed to be right here in period 6. And since Einsteinium is in this part, actually, it's kind of in period 7. So we look at the noble gas in period 6. And then we could jump to the period that Einsteinium actually is in, which is, again, 7. So 7s2 from right here. And then we hit this F block again. So 5F, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, that's the abbreviated form, which is much quicker than what we did earlier, which is write every single one of these out by hand until we got all the way down to Einsteinium, like that, all the way from 1s1. But that's how you write the abbreviated electron configuration.